we will Okay students, now we will continue with the next thing. See what is there. Now we have one final numerical on that kinematical processes. Now see this, what is that. We had solved that question. Now we will have one more question. We have two techniques. What is that? Assuming earth surface to be the base height and above the earth as positive, lesson 8 method. And now which we are solving is gravitational method, which is considering accelerating towards the earth as gravitational force along the motion that is supporting, so that it is positive. Why it is positive? Because it is that gravitational acceleration is supporting that motion. Now see that problem. What is it? Find the height of a building. If object dropped from the top, it requires 4 seconds time to come back on the earth surface. That means it is on the height is there, that building height is there, and object is falling, and it takes how much time to reach here? It takes time ts 4 seconds. Ts 4 seconds. Okay, so they are asking what is the height. Now it can be solved simple by old method. What is that? Upwards is positive, downwards is negative, so h is plus h. Okay, so what is that? If there is a height h, it is falling from certain height h, then what we can consider, because it is going to go downwards, we have considered sh minus h. See, this problem is little different. We are not different, problem is same, but this is solving by our old method, 8th standard method, 8th lesson method. That is s is equals to minus h, downwards is negative. So what we have used to do in lesson 8, downwards is negative, so a is equals to minus g. And s is also direct, that is equals to minus h. Initial velocity 0, time t taken t. So that is how we found out it takes t seconds. So we found out that height is 80 meters. So 80 meters height, minus minus would get cancelled. Okay, like that. See, in this lesson how we will solve at the same question in gravitational kinematic method. How we will solve? See, time t is 4 seconds they have given. See, the object is like this building is like this, it was thrown from here, so because of gravitational force it is moving, so acceleration will be plus g, and height is distance that it is going to cover na, so it is acquiring values plus 1 2 3, so it is plus h. Okay, gravitational force is supporting this motion, it is trying to move that acquiring distance, move, it is supporting that acquisition of velocity, right? So velocity is also positive. So putting into the equation, putting this in the equation, putting that in the equation, u into 2 is equals to half 80 square, a is again plus 10, t is 4, h is plus 80 meters. So same answer it is coming, but they just that this, understand? Okay, reply me in comment if you understand, students. That you replying motivates us to. Okay. Now next question is the similar question. What is the velocity of the ball thrown upwards in the air after 3 seconds if its initial velocity is 90 meters per second? So that is the ball. It will solve a general old kinematics method, old method, old. So when it is thrown upwards, what happens? When it is thrown upwards with 90 meters per second, they have given the after 3 seconds what its velocity will be. 90 meters per second is a very high velocity. In 3 seconds it will not turn backwards. Okay, even if it turns backwards, never mind, because general kinematics, it is always talking about displacement from the ground. Okay, displacement from what is this? From the ground, what is that? That only it will give you. Even if it turns back, it will give this displacement. Even if it is going up, it will give this displacement. It always remember, huh? Okay, but here we don't want to find displacement, we want to find velocity. So initial velocity is how much? 90 meters per second. It is general kinematics, upwards is positive, so plus 90. Okay, g is always negative in general kinematics, upwards or downwards, because it is always directed downwards, so minus g, minus 10. We have put time, they have asked 3 seconds, so just put it 90 meters per second. It was going upwards because of gravity. In 3 seconds, 3 times the acceleration, that is 30 meters per second, it was speed reduced due to negative acceleration, that is it became 60 meters per second. General kinematics, same problem by gravitational kinematics. It is thrown upwards, it is thrown upwards from the ground. This is earth, it's thrown upward from the earth, so it is thrown upward from the earth, away from the earth. u is the velocity, that it is a number, it is going to acquire है ना, त्याला काहीतरी स्पीड होणार आहे, त्याला तर पॉझिटिव्ह आहे, काहीतरी नंबर भेटणार आहे ना त्याला, that is it will go get some acquired some values, so it is positive values. That it is the process of understanding this. Okay, whatever. It is just the way of understanding this problem. not process. So it is u is equals to plus 90 meters per second. So it is going to accelerate and it will keep on reducing because gravitational force is opposing this motion, that is minus g. How much, with what rate it will oppose? 10 meters per second in 1 second. So in 1 second it will become 80 meters, in next it will become 70, third second 60, fourth second 50, next fifth second, like that. It will, when it will cover in 9 seconds it will stop, and again 10th second it will return back, so it will come back in 18 second. That also you can say like that also. Okay, so in 3 seconds by by gravitational kinematics, what you say, u is plus. Why? Because this is acquiring numbers, increasing in some velocities, values is given to the ball. Minus 10 because this value is opposed in how much time? For 3 seconds. 30 minus 90 minus 30, also 60 meters per second, that is same. So we'll stop with the problems on this principle. Now we'll move on to the next chapter, next point in the lesson, that is mass. What is mass, student? Whenever there is energy, energy is consolidated is matter. Energy consolidated is matter means what? Energy, whatever energy is there, everyone, that is consolidated, it is seen in the form of matter. Okay, consolidated, it is situated densely. So what does matter do? It occupies space. Matter is there. This was also sometime, let us say this was energy, this is purely some energy, this would have been equivalent of this energy. If it is converted, then consolidated, then this becomes this much of matter. Now what does matter do? It occupies space. There is some x-axis, before this pen was there is some x-axis, y-axis, z-axis. Now when this is placed here, it is acquiring that space, so it occupies space. It cannot move on its own, that is, it has got some inertness. Now what is, how much is this inertness? If you calculate that inertness, let us call that inertness as, by one word, call it as mass. So what is this mass? What is the mass of this object? Its inertness, how much it is tendency to oppose the motion. So mass is the also called as the measure of inertia. New definition for you. What was the earlier definition for mass? Mass is matter, matter occupies space. Now we will, now on, what is the new definition of mass? The tendency, the measure of inertia is called as mass. And now mass you understood. What else do we know about mass? Mass is the value which is same everywhere in the universe. This is mass as, let us take 10 grams, sorry 20 grams. Then this mass will be same 20 grams on moon, on Saturn, on sun, on any other planet you want. Everywhere its mass will be 20 grams only. What is the next? Its value is in kg, in SI unit. SI unit, if you take, then it is kg. I said grams, that means I said in which unit? In CGS unit. Okay. Weight. What is weight? Weight is what? The earth exerts the force of gravitation. Okay, whatever there is an object, it will experience certain weight, so it will experience certain force of gravity. That is why it is falling down. Why it is falling down? Why its state of rest is disturbed? Because force is acting on this pen. This pen is there, it should remain in space. Why it is going down? It experience force. So that force is nothing but its, the measure of this force is nothing but its weight. So what is meant by weight for us? For us, weight means what? How fat he is, how thin he is. Now no, like not like that in scientific words. What is weight? Weight is nothing but whatever the force, the gravitational earth, whatever the earth's gravitational force is exerted, that is nothing but its weight. Okay, so what is weight? Force of gravitation. You know this universal law, just put it. So what is this quantity? Gm upon d square. F of g is also equals to ma. This body is accelerated, so this is also equals to ma. This m is there here also, here also. So what is a should be equivalent to these all three quantities, because force is same on that body, even if it is accelerated or even if it is gravitational pull. So what is this acceleration? This acceleration caused by the earth's gravity, that is, it is gravity of acceleration due to gravity. So acceleration due to gravity is called by gm upon d square, that we proved out. That is nothing but g, that we proved out in the previous part. We have proved it. Yes, on page number 8, I think so. Yes, page number 8. Gm upon r square or d square, that is, d is nothing but the radius, distance, that is nothing but radius. So with that we have gm upon d square or r square. So that is acceleration due to gravity, which is g. Now this is nothing but force experience, so we can call it from now on as weight, that is mg. Now if you want this as earth, then you have to find the value of g on earth only, that is putting by the mass of the earth and distance, that is radius of the earth only. Similarly, we have certain values given in the book, that is what are the masses, what are the radius, earth, See, at moon, this you know always. This is 6 into 10 to the power 24. This is 6.4 into 10 to the power 6. That is 6.37 inaccurate, but 6.4 you can take for calculations. Moon, that is 7.36 into 10 to the power 22. 7.36 into 10 to the power 22. See, this is 24, this is 22. That means what? Divide by 100, na? So if you divide the mass of earth by 100, then you will get the mass of moon. That means moon's mass you have to multiply 100 times. So 100 moons will be equal to the earth's mass. See how interesting it is. Okay, 6 point, these powers are same. 1.7 into 6 divided by 6.37. So 17 3s are 51. So it is just 17 4s are 68. So just it is 3 times more than 3 times the radius. Okay, that is how you understood. Sun's mass, see, 2 into 10 to the power 30 kg. 30 means, if you see earth and this 34 means 6 zeros more. That means what? 10 lakh times bigger. Have mass is 10 lakh times more. You can say like that. 10 raised to 8, 6 and 8, that means what? More 2 power, so 100 times more the radius. So big the earth is. Jupiter, if you take Jupiter, if you compare 24 27, that means 1000 times more having mass. If you take about Mars planet 20 to 23, so 10 times more having mass. Venus is also having nearly 100 times, no, approximately equal, see, 24 and 24. So earth and Venus are close in mass. 48, no? So 48, 6 sides are 48. So 8 times more heavier, you can say like that. Saturn 24 to 26 means 100 times more. This is how compare. Okay, now we have, what we can do here is, we are just comparing the earth's value of mg on the equator and the pole. So what happens on the equator is, this is the body, this is the center of the earth. So by applying Newton's universal gravitation law, this should be the distance between the two bodies, inversely proportional, because we know inverse square law. Okay, but if you take about same mass placed on moon, on the pole, what would happen? Let us consider these both are same masses. Okay, same masses. Okay, but when they are same masses, so here the distance is less, so more force is applied here. Here less force is applied, so less weight here, less more weight here, because inversely proportional. So mg1 is greater, so at poles you have higher weight. Same thing that we wanted to say, that on poles we will have a higher weight. Okay, students, now we will see what is the weight of the object on moon. Okay, now what is weight? Again, you know what is weight means. What? Force of that body upon any planet is its weight. Okay, students, so let us keep an object on moon. So if this is moon, then what is the force on this body? Whatever is the force is given by gravitational law, Newton's gravitation law, that is, for weight on moon is equals to g into m upon d squared. Now this d is the distance between the two objects. Now what is this value? If you consider this value, okay, then it is this value multiplied by mass is giving you force. This value, entire value multiplied by mass of that body is giving you force. That means this body should be equivalent to what? It is trying to multiply the mass and to give force, means that body should be equals to the acceleration of that body. That is why it is equivalent to force. So we will write this as separate term, and this term is nothing but acceleration on that body due to that gravitational force. So we call that acceleration due to gravity on moon, where this is the mass of the moon and distance of the object from the moon's center, that is approximately equals to radius of the moon, because we are talking about weight to calculate on the surface, near surface. So this is the acceleration of moon. Similarly, we had calculated acceleration on the earth. Now this value we have to find. What is g on moon is equals to g of mass of moon upon distance of moon's whole squared. Now if we go on to calculate, what is that? Weight of moon is equals to g. Just now we have written weight is equals to what? G m upon d squared, and this value is nothing but the acceleration into m. So what we are going to do is g value is g, mass of the moon that we had written 7.36 into 10 to the power 22, radius of the moon is 1.74 into 10 to the power 6 whole squared. If you do the square of the whole, what we get is square of 1.4 we have done here somewhere, that is, then we have written 17 squared, that is 2.289, 7.36, so 289 divided by 7, so we just multiplied this, approximately equals to 29. 29 5s we tried that it is becoming 145, so we just multiplied it, then we found it 25 7 that it is coming near to 73, so we have written like this. Okay, so we have solved it, something like that. We have seen, you do your rough work and find its value. Weight of moon we found out this much, that is, what is this weight of moon is 2.5 into 10 to the power 10, okay, into g. What is this g? This g is universal gravitational constant, so this multiplied by m is what? Its weight. Now what should be this value then, students? This value should be equal to what? Weight of moon equals to m into g of moon. What is weight? Weight is equals to force, and what is force? Force equals to ma, that is m into a nothing but acceleration due to gravity. So this value should be equals to this value, getting, students? So this value should be equals to acceleration. Now if we want to find this value, what we can do is if we want to find this value, what we can do is 2.5 into 10 to the power g as nothing but acceleration on moon, just now by comparing. Okay, because weight of moon is m into g, it is mass into acceleration on moon, and if we want to compare these two, remove m and m, then what remains is this should be equivalent to g of moon. Now what is g of moon? 2.5 into 10 to the power 11 into capital G. What was g on earth? Just now we just in the morning we saw 1.47 into 10 to the power 11 g. Now we can compare these two values by just putting one upon another, so that g and g get cancelled, and what do we see here is 2.5 and 1.4, that is 1 by 6. So if you compare the acceleration on moon and acceleration on earth, then acceleration of earth is 1/6, acceleration on moon is 1/6 time that of on the earth. Okay, that is why we feel less pull on the moon, that is 1/6 pull is there on the moon that as that of earth. So weight of moon is 1/6 that of the earth. Okay, so how to find the answer anytime? First we have to find the force of gravity, that is equals to gmm upon r square or d squared. Then separate the value of mass and compare it with the acceleration, so that acceleration should be acceleration experienced by that body on that planet, that is acceleration due to gravity on that planet, gm upon d squared. And while after finding, don't put the value of g, just write it in the polynomial for this form, so that if you want to compare with the earth, g and g will get cancelled. So you can compare it just by putting it in this value up till like this. So whenever you will find the value of g, you will find it like this. Okay, now what is the question? Acceleration due to gravity for any planet is formula is this. We have to, where m is the mass of that planet and d is the distance of the radius of that planet. Now always remember, d is the radius of the planet and also the distance, because we are assuming that the body is kept on the surface of the earth. Yes, students? Okay, now students, we will move ahead. Mass of the object is 10 kg. What is the weight of the object on the earth? So what is mass is 10 kg. What is weight? Weight is nothing but force of gravity. What is force of gravity? G mm upon d square due to Newton's universal law. And what is this force also is equals to a into mass into acceleration. So we see that because mass into acceleration is there, and what is this acceleration? This acceleration is nothing but acceleration due to gravity on the earth. And what is this? G of earth on the earth. So if you want to compare this to, that is this coming, this is nothing but equal to g of the earth. So if you multiply mg, that is m mass into gravity is mg. So g already we know 9.8, 10 into 9.8. Okay, so this is coming out to 98 Newton. This is directly you solved it previously. Okay, this is only the step, but just that what is weight is nothing but force of gravity. That is, we have solved 2 more steps here, just not required in exam. You can solve directly. The weight is equals to mg. That also gives you the right answer. Never mind, but just see in this lesson how we are seeing that problems. Object weighs 10 Newton when measured on the surface of the earth. What would be its weight when measured on the surface of moon? So we know it is 1/6. Directly we can say like that, but see, force of gravity is nothing but gmm upon d squared. That is 10 newtons they have given on earth. Yes, what is this value? Gm upon d square. It is nothing but acceleration due to gravity on earth. Yes, that we know, because this is forces of the earth. That means mge should be equals to 10 newton. We know what do we know? That gravity, 1/6 of gravity on the earth is gravity on the moon. That means gravity on earth is 6 times gravity on the moon. So instead of writing mge, what we can write is 6 times of gravity on moon. That is nothing but equals to 10 newtons. So if we just take this c and divide it here, mg on moon, that is force of gravity on moon, should be equals to 10 divided by 6 newton. What is mg on moon? That is force of gravity on moon, that is equals to 1.66 newtons. What is force of gravity on moon? It is weight on the moon, that is 1.66 newton. Okay students, so what we have done here is we have calculated the weight on the moon. These are all the lengthy processes, that is once we have to solve it. Okay, in IIT and all this, Homi Baba, you don't need to solve it. We will practice it. As with practice we will see it how to solve it fast. So what is the homework for you? Just like we have calculated weight of the moon, when the object is 10 newton, you consider any three planets like you want in the list it is given. You can consider Saturn, Jupiter, Mars. You can consider Venus, Jupiter, moon, any three things that you want to consider, planet, celestial bodies, and you have to find their weight. Okay, find their weight. Consider that the mass of the object is 100 kg. Consider the mass of the body is 100 kg, and then you solve it as for homework. Okay, and then also we will have to solve the value of acceleration. Okay, that we can solve by the value of finding the acceleration.